So just look around yourself, guys. You will find more than like 300 people, engineers, project managers, team leads, every single one of you who has played a crucial part in the software development life cycle here at Leapfrog. So I simply want to ask you all a question, and that's not for you to think out loud, but to reflect back for a moment. So 12 months ago, what did your life look like? What was the first thing you did when you reached the office? And what was the first tool you opened when you opened your laptop? What was it, guys? Maybe it was Slack, or maybe our Gmail, maybe Google Calendar, because we have early morning meetings, right? So that part was like crazy. But if you look around, or like look into the lives we have right now, or maybe just last week, just remember what you did yesterday. What was the first thing you opened when you opened your laptop? Any guesses or what you had in the picture? So I'm pretty sure in that mental picture, you would have maybe an AI chat window open, maybe an inline coding assistant running somewhere, and maybe an agent running in the background. So the transition has been crazy. Well, the transition that we are having right now is something nobody planned for, nobody announced it formally. We did not have a specific all hands for this, but it sort of just happened. And that is exactly why we are gathered here today for. It is to know, to learn about the changes that are going to come moving forward in our SDLC. But let me be very clear about something, and that is AI is doing certain things, and that's what we call the AI-powered SDLC. And welcome to the next generation engineering with hybrid intelligence. Now, let me tell you what this means and what it specifically does not mean. Well, it does not mean that we are skipping any steps, or it does not mean that the requirement analysis is dead, or the QA is going away, or the architects are obsolete. And definitely, it simply does not mean that anyone present in this room is being replaced by an AI model. But what stays the same is the shape of the SDLC, the boxes that come into the SDLC, but something that's changed inside the SDLC is what happens inside the boxes. So here's how we've structured this whole speaking session. There are 5 speakers who will guide you through our process of the SDLC that we are currently running. And in every phase, every stage, the speakers will answer 3 specific questions. And those questions are, what a human must do? What is so judgment-driven, accountability-bound, that we can never and should never delegate to AI? Second question is, what can we delegate to AI? Where is AI thorough than us, faster than us, and where does it give us space to work on the stuff that actually matters? And the final question everybody's going to be answering is, where does the loop come into place? Where is the part where humans and AI actually work together to create real magic? So, secondly, our speakers will be highlighting the intermediate metrics. These are the metrics that will now help us understand and measure AI productivity in our SDLC. But our overall software delivery quality and the speed will definitely remain the same. It will not change. But however, AI is gonna help us strengthen it, and it does not skip any processes. So with that being said, how the AI is gonna strengthen our productivity is through better PRDs, also through stronger architecture, tougher security controls, deeper test coverage, and definitely smarter operations. So with that being said, I would like to hand it over to my AI PM, and that is Erica Joshi. A big round of applause for Erica.
So every feature in every company starts right here with me, a project manager handed over with a document full of requirements and sometimes a blank document with some rough ideas. So today it's about so today I got an email early morning saying my client requires a financial projection dashboard. So the requirement was that we need a 12-month of rolling cash projection and what if scenarios planning daily used by finance team and monthly reviewed by the executives. That's all the requirement that I've got. And I'm pretty sure we all can empathize these kind of vague requirements that we often get. So let me take you back to a year, how my day would look like. Calendar full of meetings. I'm pretty sure these kind of meetings booked by PMs are very used to with you guys. Full of discovery calls, executive sync ups, and then technical sync ups, and then follow up calls, and a lot more. Rarely any time except for this lunch break that I often keep busy so that I can have something to eat. Rest of it is full of meetings. And this is something I'm pretty sure we all here can empathize, where I rarely get some time to actually sit down and then get my time on decision making or untangle my team. Full of meetings, and what do I get at the end? A meeting note full of decisions, full of assumptions, full of questions, and full of words. This is all I get at the end. And what do? I go back home, sit at my table, and then start listening to the meeting recording again and again. And that is pretty frustrating. And I know a lot of you guys can empathize to that as well. And again, I go to the meeting minutes to make sure the critical details aren't missed. And I again and again play the recording just to make sure nothing gets missed. And a quick thing, I often ignore and I often skip some part of the meeting recording because that's quite boring. So then I go to my PRD, our favorite part of project managers. I draft a PRD with all the assumptions I've made and all the requirements that I think is true. And today it became 30 pages of requirement document, which I then pass on to my stakeholders. And then, hoping they would review it, they comes up with a reply, yes, that's perfectly okay. That's exactly what I meant to. But we all know that they didn't go through the 30 pages. They just skimmed through it. And how did I know? The PRD had some questions buried inside it, which they didn't realize, nor did they reply to me. And then I take it back to my engineering team, hoping they would read this time. And we all know, and you guys know it, if we are honest, we don't go through the PRD page by page. It's 30 pages long. Come on, guys. That's nearly impossible. Not impossible, but that's something we wouldn't do it. We skim through the requirements and then come up with technical questions. I go to my stakeholders again with a follow-up call and try to clarify the questions. And then I draft my final PRD, hoping we all got aligned. Hoping we did, finger crossed. Now, I would want to take you to today. How is it better for me? But before I go to today, I know when Suruchi introduced me, or everybody here did assume that I'm going to talk about AI. And yes, of course, I'm going to talk about AI, but before I do that, I want everybody here in this hall present, my fellow project managers and everybody, to look at this point. The role of a project manager hasn't shrunk. It has actually leveled up. And how? We are now handed over with our assistants assisting us all over. You remember when we used to imagine if we had a personal assistant assisting us on operational tasks? So we can actually sit there and do our decision making and what humans are meant to do. Welcome to AI era. Today, AI is assisting us to do all the operation work we once thought maybe somebody could help us on that. So today, it's not calendar full of meetings. So today, instead of a 30-page 30-page product requirement document, I hand over a clickable prototype which AI helped me to generate with a high-level prompt, which is now easier. And a quick heads up, it's not a wireframe, it's not low fidelity, it's actually high fidelity. So this is what I hand over to my client today. Now, they know what exactly we're trying to build. I now know that we all are aligned. And my engineers, they now know what to build. So this is now easier than ever. Instead of 30 pages, this is what I provide. And moving on. Now, instead of a very vague PRD, today I draft product specification document, which is today not ambiguous requirements, but instead it's more precise, structured, and which has a multiple spec. Also, there instead of multiple clarification rounds, today AI helped me complete the requirement upfront. And instead of engineering guessing the requirements, today they are more confident in delivering what exactly is required. And instead of misaligned bills, today it's fewer rework cycles. So this is what today the specific product specification document gets drafted. And I want to highlight something here, that this is more than ever, the requirement document that we project managers draft is highly important, because our engineers are often flexible. Whenever we give them a vague requirement, for an example, user needs to be able to sign up. They comes up with the test scenarios, the cases like password and everything. They assumes and they use their human brain to make it perfect. But today, it's not, because we need to understand that we're not just providing the specification to our engineers. It's the coding agent right behind them as well. So today, the AI coding agent, they are not quite flexible. So they execute exactly what we have specified. So if it's not in the specified document, it's not going to execute. So it is now than ever that we project managers can be able to visualize what we are building and our PRD actually going into action. So the ambiguity that cost meetings now cost a sprint of regenerations. And as I mentioned ahead, that the PRD that we document today, we can see them live being developed. And any mistakes that we make in the PRD, probably the agent's gonna execute that too. So it's now important for us project managers to make sure the specification document is perfectly crafted. So let's go through what product specification document today needs to include. 7 total sections. And we'll go through one of each sections in a while. But on a high level, it's content and goals, users and use cases, functional spec, performance and security, constraints and assumptions, what's out of scope, and the open questions. That all goes inside our product specification document. Now than ever, we need to be precise on the goals, not a vague requirement like user needs to sign up or something like user needs to log in. Now we have to be very precise, because if our AI agents cannot understand what they are building and what's the target, nor our engineers can, and nor can I. So forecast variance under 8%, dashboard time under 2 seconds, and finance users daily 40 users. So these are the numbers that are precise and not a vague requirement today. Moving on to users and use cases. If we do not know who we are building to, I don't think we are going to build a right product. So in this section goes define what to build and for who. The next section is functional spec. So here we go, the acceptance criteria we've always been crafting, edge cases, inputs and outputs, error states, and a quick hint that today it's not just me generating these. My AI assistant is helping me draft this while I sit here reviewing them thoroughly. Moving on to the non-negotiables, all the performance, security, accessibility, and audit trail. We know that we often ignore these sections until we are ready for the production deployment. And there comes Suruchi and her team saying that there's a big security issue right there. So today, it is very important for us to find this out upfront. So this is all the performance, security, accessibility, and audit trial related things goes inside in this section. Before I move on, so my client came up with a requirement again. So they said that they would like to roll out the dashboard right after we finish the MVP to their real users. As usual, I fed it to my AI gem, the same information they provided me. And it popped up with a question, how big is your user base? And I went to my client, and then they told me that there are millions of customers with their own compliance, with their own team. As usual, I again fed that information to my AI gem. And then that's when all the other requirements came along regarding their compliance. And honestly, if we had built the system with the initial requirement that was just for 40 users, we would have built a perfect product which wouldn't even sustain a month or so once we roll out to the production. So today, this is very important that AI drafted helped me, questioned me, so I know that these requirements are very critical to understand. The guardrails. So the guardrails regarding tech stack, data residency, integration, these are more critical today to find out upfront, and these all should go into the constraints and assumptions section. Moving on. This, I am pretty sure, is a very favorite part of everybody right here, saying no. And I'm sure project managers faces this. These are our favorite part as well, going to client and trying to negotiate what isn't in the scope and what wasn't planned there. So saying no is actually very important than saying, like, whatever we say as yes, it is important that we know what not to build, also equally important to what to build. So open questions, things we are still figuring out, because even while AI assists us today, there are still questions that we do not know upfront, or maybe our client doesn't know upfront. There are things we need to escalate it to our stakeholders or their executives, which is still open. Today, it is more important for us to be honest than ever. Because as I mentioned before, AI is going to execute exact thing that's in your spec document. So documenting uncertainty is definitely not a weakness, it's honesty. So these are all the section that goes into my product specification document today, being very specific. So what else do I delegate to AI? Remember I told you about my calendar full of meetings, me going to my home and then going through the meeting notes again, the meeting recordings again. And I'm pretty sure you guys can all empathize to this because we all have been through it. Even when you are a tech lead, your account manager, project manager, we all went through the meeting recording again, skipping some parts though. So these are all I delegate to AI today. So what AI does, it provides me perfect crafted what was discussed, what was the action items that was mentioned there, and all the details that I need. Except from that, all the operational works like meeting note summaries and status update draft, stakeholder communication and emails, risk identification upfront, timeline dependency mapping, progress reports, ticket creation and documentation. I know that's also one of our favorite part of project managers. These are also something I delegate to my AI. So I think I've delegated a lot of things to AI. All my operational task goes into AI. So what is it in for us humans? Are we about to be replaced? My fellow speaker, Nihal, always keeps mocking me that I need to go maybe farming. As you guys all know that I'm very much into a different hobbies every month. Nihal suggested me that maybe farming should be my next hobby. And I told him to pause right there because we're not there yet. We still have a lot of things there, human. Taste and judgment. So today, it's now very important for us to actually understand what good looks like. That's when we know whenever AI hallucinates, if we have the quality maintained, and if we already know the taste of good quality, we will be able to judge if AI hallucinated or brought up something differently. Roadmap prioritization. So I want to highlight something that we need to understand. Every business is unique. So by saying that, every business has their unique value. Yes, my AI assistant can craft a perfect looking roadmap, but as I said, every business is unique. The way they roll out things should always be as per their business and should be unique. If I let AI roll it out and maybe roll it out in the market, it's going to give me the product that looks somewhat similar to all the products out there. So this is something we human need to decide. Product specification. As I mentioned earlier, that all the product specifications for me was AI assisted. It gave me all the specifications that I needed. But today, we need to make sure that we have what we call the quality in us, which let us define what product specifications is correct, what is not. And for that as well, we need to understand what the business value is and what problem are we trying to solve. Customer interviews and research design. Yes, the research can be perfectly designed by AI, but who to talk to, when to talk to, and how is still something we humans are always good at. And the strategic challenges we face. Yes, AI can help us navigate through the mitigation plans and everything, but we humans are always good at deciding how to face the strategic challenges and how to solve it. So these are all human. So what is hybrid? Today, nothing is AI and nothing is solely me. It's hybrid. So basically, AI writes the requirement, I review it, it again asks me some questions, I again go through the answers, and then it's a loop, right? So nothing is AI, nothing is me, it's all together. So what metrics is to be tracked? Today, it is now ever easier. I'm pretty sure like whenever I draft a PRD, like a 30 pages long, I first go to the stakeholder and then I went through my technical team for the review. It stayed in my confluence, but if I have to be honest, and you guys need to be honest, did you guys ever went through the PRD before? After that? Uh, maybe not. Sometimes, maybe to look at the requirements or whenever we need to blame somebody, we go through the PRD and then mention that this hasn't been mentioned anywhere in the PRD. Come on, this wasn't the requirement. That's when we go through the PRD. But today, now than ever, we are actually being able to see our PRD going live into action. What that means is something that we missed in the product specification document rolls out in the production, and then we are able to see, oh no, that specification was completely missed in my PRD. So today, I think we PMs are more than happier today to see our PRD going live into action. And that document, particularly, which used to stay in the Confluence, today is actually something very critical that gets transferred. And I'm pretty sure you guys will be hearing this product specification document again and again and again coming up in the following speakers as well. So today, we are able to track the downstream rework from unclear scope. What that means is the requirement that we missed in the PRD, we can see it live in action. And today, it's not about blaming developers or stakeholders. We can actually check back to the product specification document. And the PRD lifecycle completion time, that's the exact metrics we can today track. So today, the specification is now denser, more tighter, and more complete and executable than ever. And today, I think I'm more than happy to see actually my PRD going live into actions, and a bit nervous because if I miss something out, it's going to be seen in the production. And when we trace back, it's actually in the PRD that was missing. But today it got more tighter, more complete, more executable. And that's exactly what I hand over to my solution architect, Sparsha Dotel. Welcome to the stage, Sparsha.
So, hi everyone. I'm Sparsha Dotel. I'm a solutions architect, which means I draw architecture diagrams for a living. Architecture diagrams are just boxes with pointers that I draw until everyone agrees that this is right, which also means that I am the first person Erica hands over that spec. This provides us the, sorry, right. This provides us the upcoming steps. That is how we architect, how we provide security, what stack should we be working on, and how we deploy into the production. And every gap or a missing edge case in that spec is a technical debt waiting to happen and an incident waiting to happen. For example, if the spec just writes, a dashboard needs to look accurate. But accurate to whom? Is this, is this the user base that is staying in Seattle? Or is that a user base staying in Mumbai? Is this for how should the data should be, right? Is this a real-time data, or do we need a daily update? Or what time would they be using a system? Is this something at the morning before they start their work, or is this something at night after they close their work? And also, how many concurrent users should be expecting? Is this just 40 users or 4 million users with 1 million concurrent users at a 30-minute time frame? Each specs begs a question that needs answering, and each of those answers will take our architecture on a completely different path. Because we need to realize that every system looks stay scalable until users arrive. And when we catch this, matters the most. Because if we catch this on week 1, we can design for it. But if we catch this on month 4 after a production release, we're going to have a whole different conversation. Less coffee, more lawyers. And because Erica has designed and created such a great specification, it makes my job a whole lot of easier. Because more precise the documentation, the better the result. And all I need to architect is the system context, the failure modes, and the open decisions that Erica has already covered. And because of that, we're going to have a whole different other meeting. Instead of I'm asking Erica and what the hell that means, and what do you mean by this, and how are we going forward with any of this, and having a meeting back and forth and back and forth, all we need to do is I can say that, okay, this is a very good documentation. I can pick this and I can design 3 more different architecture diagrams, and let's pick one of them and move forward with this. Now, once this is done, I can pass this over to Suruchi.
So thank you so much, Erica and Sparsha, for setting this up so beautifully. Because there is a specific reason why catching all these requirements in the first phase or during the requirement analysis is very necessary for me. But I'll get into it. But before that, I kind of have a question for everyone. I know I ask a lot of questions. So, do you know what happened on April 25th, 2026? Any guesses? Let me give you a small hint. It's very basic. It's related to an AI tool platform and something about a database of a company getting wiped out. Do you recall anything? Okay. So maybe for those who don't know and for those who already know, it would be a refresher. So on April 25th, 2026, I'm not going to take any names, but an AI coding agent that uses the most capable model actually wiped out entire production database of a company. And that was like what, 9 seconds or so. That's the time that takes me to come to the stage from that area. So now who are we supposed to blame? We cannot blame the tool actually, because the tool does not have those kind of privileges, or it does not have the capability to make those kind of decisions. It was due to a human in the loop. And that human who was supposed to be in the loop should have taken care of it. And yeah, what's done is done. The incident has been long due. Now we learn from that thing so that we don't face a similar kind of issue. So that's why getting into the point where Erica and Sporsha did the requirement analysis and determined that the whole product that we are going to be building is not just going to serve 40 internal users, but rather it's going to be used by millions of companies who are going to be handling financial data, critical customer data. And when we talk about those data, the security posture of simply 40 users as compared to millions of users are not the same conversation. And they don't even lie under the same roof or the same building. So far, let me tell you what we actually have right now at our organization. So SDLC had compliance requirements, but it was just a checkpoint. Or sometimes maybe like 2 or 3 checkpoints. We would have security audits going on, then we would have compliance audits, then we would do the findings, risk analysis, stuff like that. And we would raise the tickets, we would push it into Jira, and we would keep negotiating with the engineers to like, please fix this before the auditor finds it out, or if we miss the SLA. And to be honest, while we had this conversation, while we kept having these conversations, engineers would push it and we would try to negotiate down the risk and the severity. Now, that's exactly what's changing moving forward. And that is security and compliance now is embedded into each and every stage of the SDLC so that we can keep the systems and the production areas running smoothly more than ever. So that is exactly what I call Suruchi's first law of AI in SDLC. So it's very simple actually. Every new agent is a new identity, and every new identity needs to be governed. And when I talk about governing it, it's really simple as well. What it simply means for us, and it's going to mean in the future as well, is that every agent and every MCP server, every plugin, every model that we're going to be using, they all are different identities and they have to be verified. They have to be verified, recorded, versioned, scoped, and they are bound to be audited. Then we kind of enforce certain policies. And by policies, we would mean what kind of data are we supposed to share with it, what kind of access it's supposed to get, and moreover, how trusted we are with those AI platforms. And we will also control the access that we are provisioning those AI platforms with. So to govern all these areas or these agents, we have 4 pillars that help us and support us. So the 4 pillars are tooling governance, model usage, device and agent hardening, and universal compliance baseline. So in these each pillars, we will have certain to-dos, certain operational tasks that help us get more onto the ground. So starting off with first pillar, and that's the tooling governance. This pillar simply states that every tool that we're going to be using, that we are going to give access to, or whatever is going to access our data, that has to be registered somewhere. It has to be versioned, it has to be scoped, and it is definitely auditable. We need to be able to prove all these segments individually to the auditors or the regulators. Second pillar is the model usage. And this simply means what kind of tiers we have or what are the classification levels for our models. So we have in particular 3 tiers. So the first tier is the public and non-sensitive kind of information, which most of the models are fine with, and we do not need to explicitly put in any sort of control to use them. Second is the internal and business related context or business data, which is slightly narrowed list where we need to ensure that we are being strictly obedient on the parts that what kind of information we are sharing and what cannot be shared with the AI platform. And third, and that's my favorite one, and that's the third tier. And in this tier, you will find customer data, financial data, or any sort of regulated information. And this is the most narrow list. And here we need to explicitly embed data processing agreements, alongside that regional pinning, and also logging responses. Then we have the third pillar, that's device and agent hardening. And it simply talks about least privilege principles. So as you all know, before the whole AI was the whole thing, we used to stick to the fact that our engineers or developers shouldn't get full access to the production systems. And that is true to this state as well. But the only context that has changed is now we are embedding this concept into AI tools. So the minimum requirements required, the minimum data, the minimum time required to do something is the only thing that we need to stick to. So let me make it a little more concrete. So remember the agent that helped Erica create the PRD and the doc file? Does it need access to production systems? No. What is it going to do with production database? It makes zero sense. And the agent that helps Persha design the artifacts, why does it need any other access than to simply read the PRD file and design the artifacts? That's all. So anything else that is going to get access has to be reasonable and it needs to be able to explain itself. So in the future, the coding agent that's going to help Nihal, does it really need access to the production infrastructure to deploy anything? No, it just needs the access, read and write access to be specific in the dev repo. And the testing agent that's going to help Nishal, does it need any other access to the production code? No, it just needs the access to a sandbox environment and to deliver test cases. So that alignment is really critical. So the main item or the main fundamental we always need to remember is that any API token or any AI agent that we are going to be using, it just needs minimum requirements, minimum time, minimum data to do its work, and then it has to die. No long-lived tokens are supposed to be embedded into the systems because this is exactly how leaks happen. And the blast radius of this leak is no longer just your laptop or your code repo. It's going to be your whole organization. Which brings me to pillar 4, and that is the universal compliance baseline. So we definitely do not create different kinds of regime for different projects or different departments. There is a single baseline with the strictest of controls, and we simply implement it over all the projects and all the departments. And when a regulator asks, like, what has your company done or what has the project done to ensure that it meets the regulatory compliance as well, we add in the governing overlays. For example, SOC 2, ISO 27001, GDPR, or HIPAA. and anything else that the regulator of the client or the customer asks us. So these 4 pillars that we just viewed actually helps us govern all these AI platforms. Now, this is also because Provenance is the new audit log. So all the things, all the implementations, policies, controls that we put up in the previous 4 pillars, they have to be proven. And to prove them, we have certain ways of doing it. So it can be timestamp evidence, or sometimes the logs that the AI platforms actually put up, the metadata that it can consist of. So everything has to be proven. So that's why it's a new trend, and this will go along in the future as well. Now, moving on to something that's equally important. And this is something mostly ignored in most cases. And that is the vulnerabilities that are surfacing. So these are the 10 OWASP vulnerabilities for LLM applications. And out of these 10 vulnerabilities, most of them actually didn't even exist like 3-4 years ago. But now, the vulnerabilities that you see right here in the screen are the ones that have been growing rapidly in the past 18 months, past 1 year. And the most common one is prompt injection. So the most popular one for prompt injection to be in the top place is because the attackers no longer look at your code or your production systems for attack surfaces. They now look at the documents that you upload into the AI platforms, the pull requests, comments that you send out, and the Jira ticket analysis that you do using AI platforms. So we need to make sure that we avoid these vulnerabilities as much as we can. So talking about the 3 questions, what do I delegate to AI? What do I do myself? And where I am best friends with the AI platforms I use. So what do I actually delegate to AI? So actually, I delegate a ridiculous amount of stuff to AI, and I'm just happy that the AI does not come out of the screen and slap me, because it's ridiculous what I ask AI to do for me. But the ridiculous thing that I ask them to do is maybe write a third-party vendor risk assessment, or any sort of manual data collection for evidence, or continuous secret scanning. So the work that I never liked doing anyways, now AI would help me do that. But where do I come into place is when I make the risk decisions. And this is going to be there always and forever. All because I cannot give, or I will never give AI the privilege of making risk decisions for my organization. It has to be human bound, it has to be a human judgment, and a human has to be responsible for those risk decisions. So this is exactly where I come into place. Then, of course, AI is just right beside me. We always work together, and that's where we come into loop and we work together. And there are a lot of things. The concept is similar and simple in all cases. It's just that AI would simply scale up the work and I would make the decisions. For example, AI would propose least privileged scope for me, and I would review it, my team would review it. AI would help me draft threat models, and I would review it. The architects would refine it. Then AI would surface anomalous behavior, and then the security team, the human strategists, then would be drafting compliance reports. It's a long process. So it will draft it for me, and I will review it and submit it with proper approval. So now talking about the metrics. So far, we were only tracking things that were telling us what went wrong and where we went wrong, but nothing that could state how did it went wrong, or this will be the reason you might go wrong. So we are building the AI metrics for security and compliance from the ground up, and we have 4 metrics. First is the AI tool usage compliance rate, and this metric will simply allow us to measure how many approved and unapproved AI tools are being used widely in the organization. The second one would be sensitive data exposure in AI prompts. So this metric will simply help us understand and measure how many times or which projects are actually sending out sensitive information into AI prompts. Third would be AI governance control effectiveness score. So the policies, the technical controls, and all other sorts of audit-ready perspectives we are implementing, we are going to be measuring through this metric. And the final metric would be AI use case risk assessment completion time. So every use case that we will be finding or filing for the AI use cases, we will be checking their effectiveness. So these are the 4 metrics that we will be covering. So our principles definitely have not changed because these principles have been in this world longer than any organization. And they will outlive any sort of new platform, new AI tool, new tool that comes up in the next year, next day, or even in the 5 years. So the principles that we still stick to are least privilege principles. The next one is defense in depth, continuous monitoring, human accountability, and the provenance logs. So to wrap this up from my section, it's just that the spec is the contract, the security posture is a part of the spec, and that contract is enforceable, auditable, and continuous. So with that being said, I would like to call upon our developer who is going to take care of the development part after all this strict and annoying part of security and compliance. So calling upon stage Nihal.
Hi everyone, so this is Nihal, and I want to start with something obvious. AI is gonna replace us, or are they? Because over the last few years, we have seen a flood of AI coding tools with billions-dollar valuation and big promises. But I have used most of them to have a lot of you. But we know the deep truth. They actually don't address the engineering pattern. They, They generate code, they generate a lot of code. But generating code was never the hardest part of software engineering. The hardest part was generating code that fits, that respects the team patterns and team conventions. The code that 6 months down the line, the engineer doesn't have to cry reading it. But AI is already a part of our SDLC. So today I'm going to walk you through how we live in this new world. So today I'm going to talk about 3 things: Coding Spec and why this is the most important file in your code base, move Bottleneck, and the estimation earthquake. So Sparsa hands me down the architect spec, Erika, the product spec, and Suruchi guiding us through the security stuff. Now it's my job to change all this into working code base with my team members and, of course, help of AI. Years ago, I would start the project with the team conventions and put it on the Confluence page that nobody's gonna read. The new engineers learn about the team conventions and patterns by getting their PR roasted. Well, getting your PR roasted is a tradition. I don't think we're gonna remove it. We're just gonna make it less personal. So today we open Code Spec, the file, and write down explicitly all our architecture decision, team conventions, and patterns. So let me walk you through what's in our coding spec. So we do mention about the domain-driven design that we are going to use, the domain having its own context. We are also going to mention that some of the things like the forecast period, and the forecast period to be forecast period, not date range, not quarter. Why? Because our financial team uses the same exact word and the code matches the business. So next one, as Erika mentioned, that the product is going to be used by millions of users and companies. So it needs to be multi-tenant. And so we're going to mention that in our coding spec file as well and say that every SQL queries need to have tenant ID in it. So the code generated by AI is always going to have the tenant ID in the queries. And the last one is the smaller things like the money or the monetary value needs to be referenced by money object, not with floats, not with integers or strings, money object. Because in financial system, the floating point math always gonna get you. So these are a few examples, but in real world, there's gonna be like hundreds of them. And this gonna, in previous time, it's gonna make engineers difficult to onboard because um, they see the coding patterns and everything from the PR reviews. And the most of the time of the PR reviews is spent on reviewing the coding pattern of the team and to fix it. But now the onboarding is easier because the team learns the coding pattern from the coding spec. But most importantly, they learn about the business logic and those kind of stuff because the code generated by AI is already fixing those patterns and respect those conventions. And most of the time of the review is spent for talking about trade-offs. So this didn't replace engineering judgment, it just freed it up. And now, this is the interesting part and the surprising part that I've learned this year. The hardest part of our job is no longer writing code, it's reading it. AI writes code, and someone has to review it, and that someone is gonna be us. For years, writing code was the slow part, but now it has been concentrated and moved to review. You must have felt this from your experience as well, how long the PR reviews are getting and how. But now the tricky part of reviewing PR is the code generated by AI is no longer like is not almost or obviously wrong. It's just almost right. And almost right is new hard. If you don't know what you are merging, who are you gonna call at 2 a.m. when something breaks? Maybe Anistai? So now the question is, how do we review code? We have the old habit of breaking down the tickets into different technical tickets and then coding them in silos and then reviewing them in silos. But now you have to think as a product engineer. You have to build the product as the user experience it. So you take a user flow end to end from your APIs, front end, database, and tests, and then build as the whole experience that the users gets. And the good part is now you don't have to break down your stories into your smaller technical tickets like your FE tickets and BE tickets. Now AI sees the flow's full path, and when the reviewer reviews it, they get the whole context. You review stories, not puzzles. And when coding is cheap, reviewing it got expensive. Review is where engineering happens now. And this is the one I've been waiting all these minutes to talk about. So let me ask you a question. In last 6 months, how many of you sat in the sprint planning, thought about, looked at the story-pointed tickets, and thought about, this estimation doesn't feel right, but I don't know how to argue against it? Anyone? Yeah. So look at this chart. This shows the AI productivity across 2 axes: task complexity and project maturity. So Greenfield is the new code base, and the brownfield is the legacy code base where we mostly work. And when the task complexity is low in the greenfield, the AI productivity is 35 to 40%. But on the task complexity, when it's high, in the brownfield, it's from 10% to almost nothing. And internally, we have found out that 78% of tasks labeled as high complexity, like your 8 pointers or 13 pointers, were actually only taking 25% of expected effort. But 22% of the low complexity year 1 pointers and 2 pointers were taking 180% of your estimated effort. So AI, I mean, the story point was built for the time that the mechanism of how we do story point was built in the time where human wrote the code. But now, as the AI generates the code, how we estimate the story point is by this kind of 3 dimensions. One, LLM likeness. So if your task is a general task and has been seen by LLM like millions of times, the effort is almost nothing. But if it's a custom task the LLM hasn't seen, then the effort balloons. The next one is context completeness. Can you provide right context to AI? That's why the PRD or the complete PRD is important now. And the last one is human oversight. So how much does it take for a human to review the code? So let me take an example of implementing RBAC. In previous way, it's gonna be like, it looks complex. The experienced engineer is gonna say 3 points, and the fresher is gonna say 13 points. This is because the mostly story point were based on writing the code. But now, when the AI generates the code, it's fast. Everybody has the same baseline. So estimate the oversight, not the construction. So construction is cheap now, and oversight is where time actually goes. Now, 3 questions. Mostly the tasks that we do overlaps with each other, but what must a human do? They author the coding spec, review every diff. If you ship it, you have to own it. No excuses of AI wrote it. And what do I delegate to AI? The boring stuff, like boilerplate, scaffolding, PR descriptions, the other documentations, and so on, but also writing the code with the tight spec. And what's hybrid? The loop, the prompt, the reviewing or refining, and reiteration. So before I tell you what changed or how we measure the metrics, I want to tell you what changed in our software industry. Some experts says that in next 3 years, the amount of code that we generate will surpass the code that was written in last 30 years. That's a big claim, but here's the data that backs it up. In 2025, there were like 51 billion commits made in GitHub, but in 2026, it's projected to be 14 billion. So that's a 14 times jump. But what does that mean? That means coding is cheap now. But on the flip side, the review time has increased by 91% and the PR size by 154%. So that means we have promoted our bottleneck to review. And there is also a new risk in the town, comprehension risks. That's the gap between how much of code that exists in the system and how much human actually understand it. So previously, we measured the time of coding and review time, but now the writing code is necessarily cheap and reviewing is got expensive. But we do measure those things, but on top of the things that we measure how much the code generated by AI is merged into our code base and how much we rewrite that. So at the end of the day, the value that we create for the user is the most important thing. So lead time to change will always be our North Star. So we measure comprehension, and oversight. So here's the uncomfortable truth that sits underneath everything I have shared. AI makes the strong engineers with the strong foundation powerful, but the one with the weak foundation dangerous at scale. With the concept of with the concept of garbage in and garbage out, with AI generating these many codes at this high rate, if the engineers can't distinguish between what's right and what's wrong, then they might just be a liability at scale. So this is why AI fundamentals matters more than ever. Not less, not the same, more. And when it's more than human contributing to our code base, the discipline matters more than ever. Now, practically speaking, there are frameworks that helps to work around how we work with AI, like BMAT or STD, but they are not a clear winner yet. So at the rate of change that's happening in the software engineering, you must own your process with a rigorous review process as well, so that the team that builds the solid process with a strong foundation of review are the team that will not cry in next 10 months trying to catch up whatever the standards are finally working. So I want to end by saying engineering judgment became more valuable by a lot. The tools have changed, the craft has not. Looks like I'm done. But from development perspective, we are done is the dangerous thing. The tests are passing, the PR are merged, and we have deployed it into dev. But looks like we are done, right? But it's the most dangerous phrase. And it's been dangerous for back 50 years, and it's still dangerous. This is where Nissal comes in. Over to you, Nissal.
Thanks, Nihal. Hi, everybody. So this is Nishal Khadka. I run quality engineering. For the first time in my entire QA career, I'm pleased to say that I have everything I need. What does that mean? As my previous fellow speaker mentioned, the product specification from Erica, the architecture specification from Sparsa, the coding specification from Nihal, and the security baseline and compliance from Suruchi, that becomes the basis for me to create the test specification and conduct my test activities. So today, I'll talk about 5 different major aspects that falls under the QA process that has been evolving with the evolution of AI. The first, test specification. That's a unique file that's generated from all the artifacts generated upstream. The product specification, the architecture specification, coding, and the security baseline and compliance. The second, Agentic Test Generation. We obviously generate tests using AI, but there are some things that AI is unable to do and falls short. Number 3, self-healing locators. Obviously, as a QA, we write the test automation scripts, we build the test automation framework, but this is the solution to one of the most painful problems in test automation. Number 4, visual AI testing. With the regression and the effort that's put into regression, how we perform the visual AI testing using AI tools. And I would like to give you an example of how our current requirement, the financial projection dashboard engine, is verified. And finally, number 5, user adoption testing. Now, we not only focus on does it work, we focus on is it working as is it intended for the users? So let me deep dive into the first point, test specification. As I've already said, this is generated from everything from upstream. That's where everything is aligned. There is no drift. Every test originates from the exact same source as the build itself. So talking about the major components, I would like to highlight 7 of the major components within the test specification, starting with the test strategy. We build test plan. We are currently building test plan, but there are some things that we need to forecast, that we need to identify beforehand. The first thing is identifying the testing scope definition. We need to identify or forecast the risk. We need to define them based on the tiers, based on the priority, the severity of the risk. Those should be mentioned in the test specification. Those should be the highlights of the test specification, followed by the test pyramid. We all know that we write unit test, we need to write integration test, the end-to-end test, user acceptance test. Those have to be strictly added in the test specification, and we need to distribute by risk. We need to prioritize what tests need to be performed, and that has to be specified beforehand in test specification. Obviously, our application is being used by users, and we need to focus on the critical user journeys and what are the user workflows that does not go unnoticed. So the user persona identified in the product specification becomes the basis for us to identify the critical user journeys that has to be specified in the test specification. Acceptance criteria to test mapping. Obviously, we test against the acceptance criteria, and no acceptance criteria should be left alone. That is, every acceptance criteria should have at least one test. There should be the direct mapping between the acceptance criteria within the user story and the test we write so that our tests are aligned. There should be a bidirectional traceability. There should be a linkage. We not only look into the happy paths, we obviously test the negative paths and edge cases. Obviously, AI tooling has been helpful to identify the negative paths and the edge cases along with the positive cases where the QA might miss, which is a boon for us. But there are some things where AI falls short based on this. I'll explain in a bit. But the negative paths and edge cases should be specified in the test specification with the test design techniques like boundary value analysis, where one by one, one-off, mean, max field characters, whatever the requirements is specified. The error state, the cross-context interactions. Obviously, the AI tooling has been very helpful to identify this pre-hand and must be specified in the test specification. Moving on. We obviously have the functional plan, the functional test cases to carry out our test activities, but we need to think about the non-functional aspects: performance, scalability, security. We need to identify, we are talking about our application being used by millions of users. We need to have a proper performance plan. I have mentioned here, for an example, for the FPD engine, let's say the response time should be 800 milliseconds at P95. That has to be specified pre-hand in the test specification. And where are all these metrics coming from? That's driven by the product specification that's built at the beginning of our process. Obviously, when we talk about the scalability, we need to see how our application scales at large. Will it be able to handle the data? We might have to plan for the load or the performance or the stress test. That has to be pre-planned in the test specification. And the next, the visual baselines and regression. Obviously, what are the approved baseline library? If there is any mishaps or monitoring pipeline, we need to get alerts if anything goes wrong. So the components that I mentioned are the very important components that we really need to care for, and we need to add them in the test specification. Now, moving to the second part, the Agentic Test Generation. Obviously, we are generating tests maybe 70–80% of the time, or maybe even more. But what I would like to focus on is volume is not the value. Your AI tool might be able to generate thousands of test cases, but the judgment is yours. The judgment is mine. I need to review that, obviously. The 70% of the test cases might be generated, can be done by AI, let's say. But there are some things where AI falls short. It overtests trivial codes. It falls short when testing the cross-context interactions. It falls short. It misses the race conditions because it might not know the dependencies. You might be able to give it within the context, within the product specification, but it will always fall short because the intent and the context, you know more, and the judgment is yours. Number 3, self-healing locators. I'm pretty sure that my fellow QA members who have been doing test automation might be facing a lot of problems when any CSS locators get changed, your test fails. But with the help of AI, it heals itself. And this is the solution to one of the most painful problems within test automation. So AI, it does not only depend on the implementation, it depends on the intent. It locks onto intent, it survives the UI refactors automatically. It helps to review and document them properly so that what is failing, the transparency is increased within the team. You know what's being failed, what's being changed, what's being updated, and what's being fixed. Moving on, as Erica mentioned the requirement, the financial projection dashboard, users don't see the JSON. They see the visuals, the charts, the bars, the diagrams. And if the subtle broken chart that ships to millions of users is not a test failure, that's a public incident, that's a public mishap and a product failure. So that's where it becomes very important, and the AI is evolving how it can help to identify the visual regressions. AI understands the semantics. It explains in plain language that helps us to identify what's being broken. And it also helps suggest how we can fix that. And finally, user adoption testing. I know we most of the time focus our effort and time for the functional and other types of testing, but asking yourself from does it work doing the functional testing to actually is our product working as intended? Will the users use it? Are those aligned with the user's expectation? So that time is being saved by the use of AI, now the focus of a QA member can be transferred to the user adoption testing, how user gonna utilize the product. Is the expectation being met? Obviously, we shift our approach from does it work to our users actually using it as intended? For an example, with our requirement, let's say 23% of users could not find scenario comparison. And for that, I wouldn't say that's a failure in our product or how we are building it, but I would say that's a failure in adoption. So now the QA member or the team can focus on this and how to increase the user interactions, how to meet the user expectations from the product. So as my fellow speakers, we talked about like what we must do. I would also like to talk about the same thing. So starting with the test strategy creation. As I already mentioned that the judgment is yours. AI will definitely build something, but you need to review it, refine it, and based on what your context is, what your goal is, you need to have the judgment, you need to own it. The critical journey, user journey design, the exploratory testing, your AI is not going to do that. You need to do it. And now you will have the time, because most of the time for the test generation and the bulk operations, your AI is handling it. The adversarial and security testing, the approved visual baselines that helps for regression, and finally, the release readiness decision that lies within you. Your AI is not going to decide for you whether your product is ready for the production, it's ready for shipping or not. You need to do it. So as I already mentioned, like what are the things that I delegate to my AI? Obviously, the bulk operations like test generations, locator healing, visual diff clarification, gap analysis, and so and so and so. And what's hybrid? AI generates, we curate. AI flag failures, we decide what's real and what's going to work. AI proposes gaps, but the prioritization part is yours. So with the metrics, obviously it is evolving as well, and there are lots of metrics that we have been tracking, like the defect density, the different kind of test metrics. But I would like to highlight a few of them, what has become important with the evolution of AI. The acceptance criteria to test coverage, for the direct mapping and to identify what's being covered, the mean time to resolve for the self-healing locators, time to visual signal when you are running or conducting visual regressions, and finally, AI assist utilization. You need to identify what percentage of test or what percentage of test activities are you relying on AI and what you are doing manually. So with this, I'd like to talk about some of the final takeaways. As we all have been talking, no role is being shrunk, but the shift has been changed on the manual authoring part, identifying the gaps, the prioritization part, and what's left requires judgment, and judgment is yours. So with that, the label of QA has leveled up from test author to test strategist. Now, they have been uplifted from the downstream partner to the upstream partner. And finally, as the main part that we need to understand is everything is aligned, starting from the product specification to how we are testing or how we validating it, and will our product is ready for the market. And once that's all aligned, we have everything that we are able to trace. Now we are ready to ship it. Thank you. So with that, I'd like to hand over to my colleague, Shrestha. Now, what happens after it's gone to production, or what we need to do before it's ready for the production? So yeah, give it off for Shrestha.
So this is Porsche Dotel, not solution architect, but DevOps now. So we just saw a brief email that Erica got that a 40-word document go from intent to production. Erica, she wrote the spec. I architected it. Suruchi hardened it. Nihal built it, and Nishal it proved that it works, right? Now, it actually has to run. And this is the moment that has historically gone the most strong, the most quietly. It's across every deployment, every team, and every stack. Raise of hands who believe that's true. No one? Yeah, a bit slow. Because the tests were green, features were ready, everything was deployed, right? But slowly, sometimes immediately, incidents started to creep in. On-call engineers started to get paged at 2 a.m. Not Anishtai, maybe me. And infrastructure differed from what the actual design was. And costs that used to be $1,000 a month went to $10,000 or $20,000 a month. And that's not a people problem. That's a platform problem. So platform problem was always universal, right? So the drifts, the toil, the tribal knowledge, stale playbooks and everything. So just give a moment to read this, and I want to ask you a question by raise of hands again. How many of you do not have any problem, any of these problems in your projects? Raise of hands, please. No one from the bench. All right. And how many of you have at least 5 of those problems? All right. And how many of you have all of those problems? Come on, guys, interact. Rikita. Okay. Because this is something that I mentioned, this is a platform problem. So what the actual thing is a platform? If I were just to keep it vague, it is a product that we use to build our product, which means that it's a bunch of tools, services, automation workflows that we use to keep our code from commit to production, something that is always production ready and stable. So what it does is it creates like a coordination chaos that is present without the platform, and it creates a structured thingy where people collaborate and everything is visible. That thingy is called a platform. And building it has never been easier. Right now, you just need to write the intent, and it just writes itself. If you want a CI/CD workflow for GitHub Actions, you just ask the AI to write it, and it'll write for you. Ship it from GitHub to GitLab or Bitbucket, it'll do for you. If you want to create your infrastructure using Terraform on AWS, it'll write it for you. On Azure or using a CloudFormations tool, it can still write for you. So all I need to know is the natural language on what I want to write, it'll do for me. But we need to understand that we're architecting for a third class of citizens, not third-class citizens. First class of citizens is humans. Second are services. And third are those AI agents. So my infra was never built for an agent, right? So like Suruchi mentioned, we also need to consider for IAM boundaries, guardrails, sandbox environments, egress policies, the permissions that the tools can use, and most important, not for us, maybe for us as well, but mostly to the client, cost ceilings. And copying from Suruchi, we have added new kinds of actors. Those are agents, and they need new identity. Sorry, they are new identity, and those new identity need more governance. Which means that the specification does not end at deployment anymore, like Nishal mentioned, but it also needs to govern production. So what would the platform team write on the spec? Well, everything. The infrastructure on how the services needs to be deployed and where they need to do and what cloud services or what on-prem services that needs to be deployed on, that needs to be written. Hardening, something I need to copy over from Suruchi and add something of my own. The monitoring services and how the logs and everything is shipped on to those monitoring services. The CI/CD side of things. And the most important, and people usually forget, is the disaster recovery side of things, on how each and every services can fail and how we can automate those failover and how we can make things easier for those people who wake up at 2 a.m. just to fix things. And this gives us the golden path. And guardrails have to be baked in, and this all comes together as, or what we call, an agent class config. So, talking about what we need to own and what AI needs to be handed over is AI does all the work, but we need to be the ones who are responsible. So if AI does something wrong, that means we are someone responsible. So AI needs to do that is something that is reversible, observable, and the boring, and humans do the irreversible sort of things. But the most important thing that humans need to do is who gets paged at 2 a.m. And AI will help us triage things, do the RCs faster, run the playbooks, whichever is reversible, and together we observe. But now talking about observability, what do we need to observe? Because observability is not a design discipline. Sorry, observability is a design discipline. This is not a deployment afterthought. So things that needs to be observed and something that is old and something the new. Let's talk about something that has not changed and does not need to change is DORA. Not Dora the Explorer, but DORA. The metrics are deployment frequency. How often does something go into production? Secondly, lead time for changes is how often a developer commits and how quickly that commit reaches production. And change rate failure, which means if once that code reaches production, how many incidents does that create? How many rollbacks needs to be done? How many bugs have been identified? And finally, mean time to resolution is, because of those incidents, how quickly were we able to recover from all of this? And in with the new, everything related to the specifications. That's the spec accuracy, spec to deploy time, agent intervention rate, reversal rate, and so on and so forth. But this is not something that is coming on right today. But once we start working on this, this is definitely going to be maybe 6 months in the future. Because DORA tells you that the system is healthy, but the new metrics that would be telling us is that if our partnership is actually healthy. And what does this mean for our platform team? Because the platform team used to be the team that used to write the system, But today, we are the ones who write the specification for the system that writes the system. Thank you, and now over to Erica.
Because my PRD just got evolved. So see, my PRD, I told you during the first half that my PRD going to evolve and it's going to travel. So my product specification document just got deeper and denser, with powered by architecture blueprint, coding standards and patterns, security specification, and number of specifications. That then created test strategy and then powered into production. Now I can finally see my product specification document going live into action. So before we wrap up, I would like to highlight a few things my fellow speakers and my team members highlighted during their talk. That is, I know there's a lot of AI tooling, AI frameworks, AI processes are all around, and we all are confused which one exactly to look into. So I would like to highlight that since the AI-powered software development world is changing very fast, tools, frameworks, and best practices keep evolving. And what is popular today may not be there tomorrow. So right now, there's no single platform or method that everyone is agreeing on. Many different approaches are competing, and the industry is still figuring out what works the best. One important principle that stays consistent across all approaches is build a system with high cohesion and loose coupling. I'm pretty sure my development team over here can relate on this as well. What that means, each AI component should have a clear responsibility. Components should work independently, but still connect smoothly with other parts of the system. This makes AI systems more flexible, scalable, and easier to improve over time. By highlighting these points, I would like to wrap up our speakers event and hand it over to Sayomi.